I back again here. Share. Yes. Sharing now, yes?
Yes.
Okay, we can cancel this. Q is given actually 0.07 meter cube per second. But we use this equation to get V actually. H pump. How to get H pump?
Bernoulli's
Yes, energy equation B over gamma
P bar
plus
gamma
Z
Z
plus V square.
square over 2G plus H pump equal
P upon
P
gamma
P by gamma plus Z V
plus
square
Z
by 2G
V square over 2G plus
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 H log. Okay. Any information here about pressure? No, there is no information about pressure.
atmospheric.
Consider as atmospheric. Any information about the division?
No, Z cancel.
That's it, cancel.
V square by 2G.
Any information about velocity?
Yeah, we should fight from.
We can get it from Q, correct?
Yes,
Yes.
sir.
Don't
Q
notice
value is Q.
diameter not change along the pipe. It means the velocity not change. All problem cancel. We can cancel HQ with HL, correct?
And what we will find out?
HV is equal HL. All see the problem is very easy because HP is equal HL. No, actually we start the problem now. HL, how to get it? F L over D V square
By 2G.
by 2G. Yes, correct. If we have L, we have D also, G is constant, the remaining is V. What we will use?
Yeah.
Happy face.
Yeah.
Okay. How to get it V? We can here for side calculation.
Q.
V equal Q over A. V equal 0.07 meter cube per second.
By 4.
By over 4.
Into 0.2 whole square.
From this equation, you can get V. Okay. If you get V, tell me. HP equal F, which is 0.02. L, 1 kilometer shall be converted to meter, correct? Divided by D, 0.2 direct. 0.2 to be meter here. Okay. V square over 2G. Multiply V square. What you get it from here? What is square for this value?
Yes.
Divided by 2G to multiply 9.81. You can
Yes, sir.
get this value by calculator
Yes.
direct. Just multiply this one times this one times this one square divided by and they make bracket, then multiply this together or close the bracket and press
It's
equal.
all multiplied to one time. Denominator.
But this should be between bracket, okay?
Okay.
After close the bracket, press equal, get the total answer for HP direct. Okay? Now we have HP, we have Q, we have gamma, we can get power. Clear?
Yes, yes.
Yeah. Any question for this problem?
Easy.
Easy. Alhamdulillah. Now it's easy.
First time, sir, calculation easy. After
Yeah.
long.
More practice is better.
Yes, yes. Now it's
But
better,
please, if
better
it's
than
easy,
before.
don't stop at this step. Please make calculation by calculator. Don't
No, this
keep the calculator at the end on the exam. Try to make practice for calculator to be easier for calculation. Okay. Answer is 17.4. I give you also. I think this problem for this one of the problem in the exam. You remember we kept number 10 and 14. You remember? I tell you we will solve it during session for bumps.
Yes,
I
yes.
think this one of them and this next one here, this one. I think so. This yes. One of them is 10 and one of them is 7.
Small fire vitamin to carries water. The president shooting. Similar type question, only elevation. Only Z will be varying.
But not the elevation. There is
Yes.
no losses here.
Z2, Z1, Z2.
Yes. All finished reading. Here you talk about for a small pipe. I put this for a reason because many just once they see small pipe. Yeah, there is no friction for this one, no friction factor. No, wrong. Even if it's small pipe, still we have friction factor. Okay. It is a small value or the smallest value, but still we have. Of diameter 200 millimeter carries water. The type of the flow is water. 200 millimeter, it means 0.2 meter for the diameter. The pressure in the pipe at section S1, elevation 10 meter, is 50 kilopascal. At section S2, elevation 12 meter, the pressure 20 kilopascal. And velocity is 2 meters per second. The velocity here, 2 meters per second. The density of the water, 10 to the power 3 kilogram per meter cube. And acceleration due to gravity, G 9.8
1.
meter per second square. Which of the following is true? Actually, I don't put now the choices, okay? Because I solved the part of white here, I will continue solving. But I tell you the choices. The choices he asked for, the direction of the flow from S1 to S2, and value blah blah. Second choice from S2 to S1, another the same value. Then S1 to S2, different value, and S2 to S1, different value. Okay? It means the question is divided into questions. First one is direction. First one is direction. And second one, losses, H losses. H losses value. Okay? Okay, one by one. Write the equation first. How to write the equation? Energy equation. B over gamma plus Z plus V square over 2G. No bump, no anything. Okay, it means equal. B over gamma plus Z plus V square over 2G plus H losses. Correct?
HP no here, huh? Pump.
No bump here. The flow is moving regarding different pressure effect and elevation effect. Someone tell me, no, the elevation from large to big, from small to large, or something like this, the flow direction is blah, blah. Correct? What you expect? Anyone, you can check the direction without calculation? Anyone can check or guess the direction without calculation?
Direction is towards S2.
From?
S1. No, S2 to
S1
S1
to
due to gravity.
X1 to S2?
S2 to S1.
S2 to S1.
Why S2 to S1?
Due to gravity.
Due to gravity from 12 meter to 10 meter?
And elevation is here more and
Elevation.
here elevation is
12
less.
to 10.
Yeah, actually it is correct, but in case of this only the variable effect. But actually we have two parameter effect here. What is this two parameter? Pressure and elevation. Actually, if you check elevation 12 and 10, it's okay, I agree with you. But in the flip side, you can see 20 kilopascal and 50 kilopascal. Actually,
Yes.
the flow also is going from the large value to the low value. So we can take a decide. We can't decide for this one easily like this. Should be by calculation because this is two opposite together. Correct?
Yes.
Finally, we can't expect which one is dominant for this problem. Okay, so we need to substitute direct. Okay, after substitution, how to know the direction of the flow? The concept is if we have energy here and this energy going to another point, expected energy here is less or more?
Yes.
Less due to what?
Friction loss.
Due to losses. So all the time, losses and state 2 equal to state 1, correct?
Yes.
So I put here H losses with state 2, which I guess state 2 is the final state. If H losses at the end, you get it at a positive value, it means you are correct for what you expect. But if the losses get it by negative value, it means should be in other side and the direction from 2 to 1. This clear?
Yes.
Yeah. Let's start. Pressure here,
50 into 1000.
yes, 50.
Ten
But
raised to 3.
50 watt times 10 to the power 3.
Yes.
Don't forget. Divided by gamma, which is 9.8 times 10 to the power 3. This is rho.
Into 10 raised to, yes.
Plus Z. What is Z?
Elevation
10 meter.
10.
Okay, V, velocity. You expect you need to substitute by velocity 2 meter per second, or you need to calculate the velocity?
Calculate the velocity.
What is this? Diameter. Diameter change.
Velocity also changes.
Velocity not a change. Diameter not a change. It means velocity not a change according to
Q is equal to A.
Yes.
clear. Clear?
Yes.
Yes.
Don't lose time for calculation. Equal to other side, which is 20 kilopascal times 10 to the power 3, 9.8 times 10 to the power 3, plus 12 plus H losses. I think from this equation you can get what? H losses direct. Also, we can get it easy. 10 to the power 3 with 10 to the power 3 cancel. 50, we can approximately this as a 10, it means a 5 plus 10 equal, cancel, this 20 divided by 10, which is 2, plus 12, well, plus H losses, 15 equal 14 plus H losses, which is H losses approximately 1.
Positive.
It means that the direction of flow from S1 to
S1 to S2.
Clear?
Yes.
Okay. S1 to S2 and the losses head 0.5? No. Different direction but the same value? No. S1 to S2 and 1.06 meter? Yes.
Answer C, third one.
It means the third one is the correct one.
Yes.
Any question?
No.
What is this? This Moody chart. Moody chart. Actually, Moody chart I bring it to remember refreshment sum description for friction factor. But actually, recently, one question coming in the figure itself. The figure is coming with some curves on the curve, on the figure, and ask it for one question. I will tell you the question for the exam coming for this diagram. Actually, Moody charge. What's the important notes here to be should be no? First thing, this one is friction factor itself. This F, this friction factor, okay? And this reduced number, the other axis, this is the axis, y-axis, this x-axis, reduced number. And other y-axis here is relative by roughness, relative roughness, relative what? Relative roughness. And equal to what relative roughness? Epsilon over d, epsilon over d. D refer to what? D refer to the diameter of the pipe. Okay? And epsilon refer to what? Refer to the roughness of the material. It means it depends on the material. Same like the problem mentioned, this one have a GI, type of GI. This epsilon, what is value for this epsilon? From table, just table, have information for each material, whatever is the type of the material, for example, concrete, for example, iron, and so on. What is the type of your material? We can get the value of epsilon. And this is millimeter to divide millimeter by millimeter, diameter also here by millimeter, to obtain relative by dimension. Here, this dimensionless curves, this dimensionless values represent the form.
Please unmute to the please.
Yes, thank you. This lines, you see these lines slightly curved from below, and here almost a straight line. You see this line? This line starts from here and goes straight like this. Starts from here and goes straight like this. Actually, this line represents for relative roughness. And the pure horizontal line, this for friction factor. Pure vertical line, this for reduced number. Here now. So to calculate the friction factor should be at least you aware the value for reduced number from this side and the value for relative pipe roughness from this side to make intersection and going to the left to get friction factor. Clear? Okay. This first thing. Second thing, the classification here. You will see here this line is linear line, straight. Or not straight, this linear line. This linear line represents what? A relation during laminar flow. So the relation for friction factor between reduced number to get the friction factor is linear. Is what? Linear. It means for laminar, L for laminar, F equal 64 by reduced number according to this line. You can get it from this line or from this equation direct. This linear. But turbulent is curved like this. Okay, this turbulent. What is important here is this first curve. You see this line? First curve here, this line. This first curve represents for smooth pipe. The question asked in the exam, just to bring the figure like this and mention here like this, and some curve like this, and mention here A, B, C, D. And the question is the curve for smooth pipe. The curve for smooth pipe. A, 2, B, 3, C, D, 4, D. Which one?
A.
B.
Sorry, B.
B.
Yeah, B.
Many is select A according to we talk about for smooth, it means something linear, something no friction, something, any something. But actually, according to the Moody chart, the correct answer is the lowest curve in the diagram. It means answer correct is what? B. It's clear question?
Yes.
Okay.
This,
This UPDA exam, yes.
sir, this laminar flow, you said, then how to know
Laminar
about
for
this
A.
turbulence, sir?
Laminar for the curve A and the range to
Yeah.
laminar up to 2,300 reals now.
Yes.
Then
2300.
turbulent start from 4,000.
Yes, between two transient.
This area, as you see, small area here.
Then how about this
And this area is here is represented as a small area because this logarithmic scale, this not regular scale, this log scale. So this range is small for transient here.
This turbulence.
What's your question for turbulent? Turbulent starts from 4,000 reals number.
Okay.
Any more question?
In this drawing, from where is started turbulent?
This one is starting from this curve here. Only between this is transient. After this line, turbulent. Actually, after laminar, we can consider as a turbulent. Consider it's transient. Not actually after laminar.
Why is
Any more question?
No, okay, no.
The part of net positive suction head. This part is also one of the important parts in the exam. Numerically or theoretical part. I just bring something for this. No, just yes. Net positive suction head. As we studied before for the symbol for PDF file, we describe the general calculation or the general equation for net positive suction head, which is equal to suction pressure minus vapor pressure. And then going to the one more detailed equation for calculation of net positive suction head available, which is equal to head of atmospheric and head of static, and the head of the surface, static, head of static, minus the vapor head, which represent to the saturation pressure or vapor pressure, and also losses. Finally, we can write the equation like net positive suction head available is equal to H atmospheric. This equation same this one and same this one, not different, but this in pressure form, But normally in the exam, we calculated as a form of head form. H atmospheric plus H static minus H vapor or saturation, both the same. Sometimes we mention saturation, minus H losses. Okay, let me check with you H part. For first one, H atmospheric, which is referred to the atmospheric pressure for this topic. For example, as you see here, you see this one, this example, the pressure for this reservoir is a part of H atmospheric. If this tank is closed, this should be represent the tank for enclosure here inside. It's not at all atmospheric, no, because normal, the almost all examples is the flow coming from the suction side for big reservoir. So no, all the time regularly H atmospheric referred to exactly atmospheric, but sometimes the reservoir coming as a closed tank. So the pressure should be the pressure inside. Meaning of this part clear? This is the pressure at the surface here. Clear?
Yes.
Second one, HST, H static. H static, what is H static? This is the height from the level of reservoir, this level of reservoir, to the center of the suction pipe. This is a pipe of suction. This suction pipe, correct? Suction pipe from this point to this point. This suction pipe. The distance from the center of the suction pipe to the reservoir level, okay, this distance, which is here BZ, this H is static. This what? H is static. Okay? This measures the direct from the problem. I will show you one problem, but in the exam 4, I think so. It should be measured direct here, calculated direct by geometrical measurement here. Okay. Third one, H vapor or H saturation. This is normally given in the exam. Just mention for some information for initial temperature and something like this, and the given H vapor pressure or vapor pressure as a function of head. For example, sometimes it's given as a PSI as a pressure and converted to head to calculate it in this equation, and sometimes given direct by feet, direct feet of head, for example, or feet of water. So this represents for head. Last part, this is the losses. You remember losses? Equation of the losses? This is the losses actually. And these losses should be calculated for the pipe from the beginning here to up to the end here for the suction loss. It means this all terms is related for suction side of the pump. Suction side of the pump till the end of the suction side. All related to suction side. So H losses here calculated for this pipe. For example, here we have closing from large tank to closed tank, small pipe. Here we have elbow, for example. Here we have maybe small pipe to sudden large area, for example. According to the K factor given, K factor for elbow, K factor for this one, whatever given in the exam, calculated for the K factor given. Otherwise, don't think for anything. Just focus for the given for the factors like K for this one and so on. Calculate for this. And this is a part for minor. For major, calculate losses for total length pipe. Total length pipe. As you know the equation L over F, L over D, P square over 2G. From where we can get F, normally given in the exam, F. L over D is the length of the diameter, length of the pipe, D is the diameter of the pipe, V is the velocity inside the pipe, and so on. Okay? If you have any question for this part, tell me. Before we going to another part. Any question for net positive suction head?
No.
What is the formulas for HL?
HL, this the formula we studied in the previous slide. HL equal F
L by D, V square by 2.
V square, okay.
Plus K, V square over 2.
Okay.
I tell you something. This equation, if need to calculate for this equation at exam, normally not coming. Sometimes it's coming, but sometimes not coming. The equation itself, not given as a formula. So keep in mind.
So if it is only asking about the pipe, means we should not write this, no sir, K into V square by 2G, this component. Only if he asking about pipe means F into L by D into V square by 2G.
This, yeah, according to the problem. But for this problem, for net positive suction head,
complete we have to write.
He don't mention to you what you need to calculate and why not. Okay? So how to know all calculation or this part or this part according to given. If give information for this F and other information, you need, it means we calculate measure. If you need the K and some information for K for fittings, it means this one should be also included in the equation.
Okay.
Okay.
Got it. Thank you.
Welcome. This we solved it already.
Solve that.
Okay. Thank you. Enough today. We're going to next part. Exam 2 now is totally finished. Okay.
Yes.
Yeah.
Second part, I will start here. We will start by NFPA. Okay. I finish first NFPA and then going to thermodynamics. Okay. For NFPA code used in the exam or need to be covered in the coming exam. Actually, for what is NFPA is National Fire Protection Association. National Fire Protection Association. NFP1 is fire code. NFP 10 and 13, 14, 20, 22 is related for firefighting. 10, 13, 14, 20, 22 is related for firefighting. 10 is focused for portable fire extinguishers. This is just regular extinguishers. And 13, talk about for sprinkler system. All details related for sprinkler system. 14, this related to standpipe and the hose system and the fire hose reel. This 14. 20 focus for pumps. I just make now mmup. This part.
Slide not showing, sir.
Not show. Slide show. Not show.
No, only green international only.
No slide.
Okay, is this clear now?
Yeah, no, it's okay.
What is happy?
Yeah, happy.
Okay. Happy, it means AV. This is short.
Happy, yeah.
He was enough to smile.
And Modi is Modi, our
And
PM.
what?
Modi is our Modi, our PM, Indian PM.
Yeah.
Modi.
Yes. Okay. This is what I discussed before you slideshow here. NV 10, 13, 14, and 20, 22 is this related for firefighting. 10 and 13 and 14, 2022. 10 related for portable fire extinguishers. 13 related to sprinkler system. 14 related to hose system, fire hose reel and standpipe. 20 related for pumps, fire pump. 22 is related fire water tanks. Okay. NPA 70, National Electric Code, talk about or focus for electrical. 72, National Fire Alarm, very important. If you are mechanical, you cover everything. You can coming from electric, alarm, civil, you are mechanical. It means you are hero, okay? 88A, this and 88B, this covering the part for parking. 88A and 88B, this related for parking and repair garage, okay. 92 And the subtitles for this 92A and 92B all talk about for a smoke control system. It means focus for mechanical ventilation. Focus for mechanical ventilation. Okay. 92 is a standard for a smoke control system and divided to two parts. But at all, 92 focus for mechanical ventilation, smoke control system. 96 is standard for ventilation control and the fire protection of commercial cooking operation. It means we focus for 96 to commercial cooking. Sorry, back. Commercial cooking here. Where? Yes, this one. Commercial cooking. It means anything related for kitchen. This focus for NFPA 96. 99, he focused for healthcare facilities, any design related for hospital and pharmacy like this. This healthcare facilities code is NFPA 99. Okay, especially for the specific parts like healthcare facility, like commercial cooking. Normally in this code itself, he talk about for firefighting and alarm and mechanical ventilation, everything, including the part itself for NFPA code. Okay, 1.1. Oh, this one is the important code, life safety code. This is the mother code here, life safety code. Okay, 170 is a standard for life safety and emergency symbol. It's not important, just this is to represent the symbol used for regular design. 203 is important. This focus for also mechanical, for ventilation, but here for smoke and heat venting, it means related, most related to natural ventilation. Okay. 2001, this focus for clean agent and clean agent fire extinguishers, and normal automatic also. Like FM200, for example, for substation, used for substation, and the other clean agent you can use be used. Okay, this focus for clean agent fire extinguishers, aerosol, for example, ansol, and so on. 5000 building construction and safety code. This normal is a important codes, important, and we will focus here and the coming in the exam. Okay. Okay. Kindly all, you can open mic or you can share with writing. First question.
C.
Semi-annually.
Yeah, inspection of fire alarm system is annually.
But how can we understand, boss?
This for not understanding. This for to be remember and save it. Just make photo by eye, photo figures by eyes.
Oh, means only remember, huh? No any logic or no any.
No, the only logic when I going to the exam, I try to just make the anything figure out for this part, for example, which is not regular. For example, default is for inspection or testing for alarm system is annually, and default frequently inspection, for example, semi-annually. So this is a regular, but I focus more for something quarterly, something monthly, this little, not more. Regular is semi-annual and annually. So I don't need to save it.
There is a chart in NFP, you know.
So we have to remember all things.
Yeah. I try to focus more for the out of the box. What is the odd? The focus for odd, and the other is regular. Frequently inspection of heat detector.
C.
Detector.
Monthly.
No, semi-annually.
Semi-annually.
Frequently inspection for almost all alarm systems semi-annually. And testing normally annually for alarm system. We will see here some special and specific questions. Answer is quarterly or monthly. Maybe monthly is maybe one question or something like this. Okay.
How many questions come from NPA? 2?
2 or 3 maximum, something like this. But not all like in inspection. Sometimes asking for the code itself and so on. Answer for third question.
Annually.
Annually. Testing of field detector is annually.
Okay. What will you remember?
Zone control valve inspection is
Quarterly.
Quarterly?
Semi-annually.
Semi-annual.
No
This
guess.
visual inspection. This one of the odd questions.
Monthly. Sure.
Yeah. This one I save it. This is not regular. Okay.
Alarm box. Monthly.
No, back again to the original.
Annually.
This testing.
Oh, shit. Okay.
Annually.
Semi-annually?
For sure.
Oh.
I think this one also odd. Maybe I don't remember actually.
Quarterly.
No options displayed.
This option.
Quarterly. Till now, no any answer quarterly.
Quarterly.
Annually.
Still coming a question. Maybe you found the quarterly. Don't worry. Audio device.
This is
Your device?
annually.
Annually
testing.
More answer annually.
Yeah. Visual inspection of audible device.
Audible device
Monthly.
Semi-annually visual inspection. Testing of water flow device.
Quarterly.
This sure.
This one of the odd question. The odd question is little. Inspection of supervisor.
Signal device.
Quarterly.
Now coming.
Yeah. I will give you one gift after we finish.
B. NFPA 88.
88.
Something 88.
It's easy.
88 for car parking.
Yes, correct.
88. Good question.
Okay.
C. NFPA 92.
Yeah.
Yes. 92.
92. Yes.
Correct. Sprinkler system.
B. 13.
13.
Sprinkler.
Correct.
Sprinkler.
Which one of the following is not a unit of dynamics? Viscosity.
Stocks.
Correct.
Stocks.
Water flow between two plates, of which the upper one is stationary and the lower one is moving with a velocity v. What will be the velocity of the fluid in contact with the upper plate?
0.
0. And lower plate?
It's V.
V.
Yes.
Anyone have a problem for this question?
No.
None.
Clear for all?
0.
Which of the following can't be used as a biomaterial?
Biometal, ceramics, polymer.
Polymers.
Polymers is a biomaterial?
Yes, polymers is biomaterials.
None of them.
No, polymer is not a biomaterial. Biomaterial like anything like tissue, for example, from human body.
No, D. Not
None of the mention, yes.
None of the mention.
Body will regain its previous shape and size only when the deformation caused by the external forces is within a certain limit. What?
Elastic limit.
elastic.
Elastic limit, great.
Elastic limit.
B.
Yes.
So here is a question, but don't keep in your mind these choices may be wrong, but think for the problem. We have here two questions, this one and this one. Just answer for the first one. What is the equation will be used?
Yeah.
Right.
Which equation would be used here? Bernoulli.
Yes.
But according to the required, he needs this charge. To calculate this charge, we need.
Heavy.
So,
So Bernoulli equation to get the V, B over gamma plus Z
then plus v square by 2g.
B square over 2G
2G.
equals B over
H.
gamma plus Z plus V square over 2G. First equation, neglect losses without losses. Pressure, this is atmospheric at point 1. I will apply here between point 1 and the point 3 because the charge required at the outlet here at 3, correct?
Yeah.
So the pressure 1 and 3, this open to atmospheric, this open to atmospheric, correct? Z1 equal to what? Z1,
Z1 0.
Z2 or Z3. Z1 is H. If I put the datum here, it means Z1 is H.
Right.
Correct?
Yes.
ZH. Velocity at 1, this open and decrease for the velocity almost 0. Means H equal to Z3. Z3 is equal what?
0.
0 on the same datum. Velocity is the velocity at the orifice which is required, V square over 2G. So the velocity at the end here from this equation, we will find the velocity is equal to rho GH. Correct or not?
Yes, yes.
Just substitute, direct substitution, V equal 2 times 9.81 times 3.8. After you get the value of Q, V, you can get the Q, which is equal to pi over 4 d square, which is 0.05 squared times velocity. Correct?
Yes.
This for first stage for the problem here. If you need to calculate for the second stage, considering the losses of head to be 10% of H, just we need to add here part of what?
H loss.
H losses, that's it. The same equation. It means at the end you found this is step, this equation, H will be equal V square over 2G, but plus H losses. Correct?
In both situations, saying that first we should neglect the head loss, and second we should consider the head loss.
Yes.
10%.
10%. It's the same equation here. This is the last step. Just we added here H losses, here H losses. So the end of equation H equal V square over 2G plus H losses. So we will find this the same equation for velocity equal to root H minus H losses times 2G. Correct?
Yes.
This is the only difference. Not total H, but H minus H losses. H minus the losses. And the losses is 10%. It means this point here is 0.9 H. That's it. And continue the same problem. Clear?
H minus HL.
Yes, H minus HL. HL is just we put this side, other side, this one, H losses. We put it in other side. Here it means H minus H losses. H minus H losses. Then
Sir, H minus H L means H value already we got from this 3.8.
I will write it here. No problem. Is this finished?
Yeah, this finish. Okay. This
Okay.
first.
I can open whiteboard quickly, and we can write on whiteboard. The equation H, sorry, B over gamma plus Z plus V square over 2V equal B over gamma plus Z plus V square over 2G plus H losses now, correct? This
yes.
atmospheric, as we canceled before, this Z is H, this 0 because a large reservoir equal to Z here 0, V square over 2G plus H losses. He mentioned H losses in the question is 0.1 H as we're given. So H equal V square over 2G plus 0.1 H, correct?
Yes.
It means H minus 0.1 H equal V square over
by 2G.
So V equal the root of H minus 0.1 H times 2G. This is what we write in the equation.
Yes.
H minus H losses times 2G. And continue again. Q equal AV, but we multiply the area and the new velocity now. Clear?
Yes.
Okay. Finish whiteboard?
Yes. Sir.
Yes.
Sorry.
Sir, this is exam 3. Or what? No.
I will share with you exam 3. Okay? But when we need to start for exam 3, I will share it with you. Continue. Before starting work outside, the major factor, be focus, please concentrate for this major because you talk about major. It means one. I need one. Okay, major factor has to be
It's
checked.
D, approval from
D.
approval from the MMUP, civil defense.
Approval from MMUP civil and defense.
But should be taken approval. Okay, don't forget. What is the number that measures an object resistance to being deformed elastically when stress is applied to it?
A, elastic modulus.
Elastic modulus.
Elastic modulus.
Elastic modulus.
What is this point? B.
Breaking point.
Breaking point.
Breaking point. Prevents the spread of smoke inside the duct and the fire resistance rating.
Fire damper.
Fire damper. Firefighting water sprinkler cover a maximum distance of
15 feet. C.
C. Any other have other answer?
No.
Actually 15 feet, which is referred to 4.6 meter and light hazard. How frequently a portable fire extinguisher according to NFB 10 should be checked?
Quarterly.
Without debate for these questions, you can check your car. Check your car. You have a portable fire extinguisher in car?
Yeah, yearly.
Annually.
For the renewal.
Annually. Okay, thank you. This second, thank you, but we have a third one today. Okay.
Again, third, sir?
No, this second one. We have another one. This not yet, not finished yet. NFBA finished. NFBA slide finished. Okay.
NPA all finished, huh? All khalas.
or خلاص, but I will give you something. This gift from me here. I sent you by WhatsApp, I think so. Where is
WhatsApp.
it? I will check first. Is this one or another? Not this one. Because actually, alarm testing in NFPA 72 in alarm test code is very huge. I have another one. Just give me 1 minute. Just I checked. Where is it? Where is it? Maybe I think so. It is here. The file I will send you. This file I found it during search. Yes, I found it here. I will upload it now to you. Just a minute. Because my PC will be shut down suddenly. Just put a charger. Quickly. Yes, I get it. Okay, I will share with you now the file. This file actually more simple for the sum testing for many different categories, but in simple way, not more details like NFPA code. I sent now. You can check. I will open with you now.
Yes.
To check with you. Okay.
In Zoom group you shared, sir?
I sent you on the group, yes. Check on the group, please.
WhatsApp or this Zoom you shared?
WhatsApp, yes. And I will open with you here now. I open now here. What? Okay. Share, starting share.
Too much, sir. So many pages.
Sharing now. You see the sharing?
Yes.
Yes, this file here. As you see here, this have some attachment. Focus for this attachment. If you're going to A1, you found the summary for each regular testing or inspection for each one. The formatting for this, I see this one easier more from the NLPA. For example, let me really check, for example, automatic sprinkler system, for example, this is just example, or fire detection and alarm system. Going first for automatic. Here, if you're going, just to go, you found summary like this. An inspection, testing for focus for the element related for sprinkler. That's it, and finished. Okay. Not all is important, but if you check the important things like controlled valves, like alarm devices, like sprinkler itself, something like this. Okay. Fire hose reel, if you found fire hose reel here, for example, if you're going back to check the fire alarm one, because the fire alarm, as you know, is the more question coming, fire detection and alarm system here, you found the same. Just in a simple pages, not big. You see big because it has many devices, but actually we will focus also again for the important things, like we will focus, for example, to detectors, for example, duct detectors, like fire alarm boxer, like heat detectors, like smoke detectors, supervisory signal device. This is a regular the water flow device. This is a regular questions coming. Okay. You can check here inspection and going again for the same to the testing. It's very beautiful. I found it actually. If you check a firearm NMP code is so difficult than this classification and everything. Classification here is very good. Okay.
Okay.
Okay. Going now. Now NMPA code finished. Okay. Now I am satisfied. The presentation and this file is enough for NMPA. And we will see some question also during the exams. Exams we solved it here. Each exam you will find 1, 2 questions, 3 questions for NMPA. Okay, going to the next part. And the next part for thermodynamics. Okay. Here, yes. For thermodynamics. Okay, next slide show now. Share a slide. All see the slide. Slide is clear for all.
Yes, sir, clear.
Okay. Actually, for the part of thermodynamics. This part of thermodynamics, we have some information theoretical, many information for principle, but also we will focus for some important equation and equation for that. So here we are going to know what is pressure, temperature, some information like volume, energy, work, power, heat. Okay. Actually, what you feel?
Heat.
Heat. This heat coming created this called thermal energy. Thermal energy. Thermal energy. Thermodynamics is the study of the effects of work, heat, and energy on the system. Here should be no the different meaning between three terms very critical and very important. Maybe I think the exams 3 have one question. I bought it from the exam for repeat exam related direct. It is not a mechanical question, but it's solved pure from mechanical concept. Actually, here mentioned for 3 terms: system, surrounding, and boundary. Should be know and to be clear for all what is different and what's meaning of system and surrounding and boundary. When you do anything in your life, should be know what is the system you will study for your problem, what is the surrounding, what's the boundary. If you stay now in room, it means you and all and everything inside this room, it is a system to be studied. If you wanted to study your room. And the boundary now, it is the wall and door and the windows for this room. This all is boundaries. And anything outside this room, it is the surrounding. Clear? Okay. What is difference between thermal energy definition and temperature? First, we start by thermal energy definition. Thermal energy definition is a kinetic energy. I stressed for the some letters or some words because if you check the question and you found something referred to this meaning, you can get it the answer direct. Okay? Please focus and with me, especially for the stress words, play it in the exam for that. Thermal energy is kinetic energy, it's concept. Intransient from one object to another due to temperature difference. Kinetic energy intransient from one object to another due to temperature difference. And we have some units used for that, as you see in the slide. Temperature is the average kinetic energy. Still, it is referred to kinetic energy also. But this average kinetic energy of particles in an object. Not the total amount of kinetic energy particles, but is average kinetic energy of particles. So for this body, we have temperature according to the average kinetic energy for particles for this body. And for another object, also we have temperature according to the average kinetic energy of the particles. But due to temperature difference, we have thermal energy passing through from the hot body to the cold body. Just here represent the difference between the temperature scale. As you know, the temperature scales, you know, Celsius and Fahrenheit. These are two main scales used. Celsius, range of this one, 0 Celsius for the freezing point and 100 for the boiling point. It means delta T between freezing and boiling is 100. This is the range. But in Fahrenheit, the 0 or the freezing point is 32 Fahrenheit. And the boiling is 212 freezing point. It means, boiling point, it means the difference in 180. Difference is 180 between freezing and boiling for Fahrenheit. But for Celsius and Fahrenheit, this is scale not start from the origin. It is a linear relation. It is a linear relation, okay? But this linear relation, something like this. Not start from origin. So scientists need to revise this curve to start from origin like this. What he will do? For the Celsius, just revise to B, start from here, and this measure as a new scale is called Kelvin. And this distance is 273. So the conversion between the Celsius and the Kelvin, 273. Equivalent to this one, we're going to make equivalent to Fahrenheit. The equivalent for Fahrenheit is Rankine. The equivalent for Fahrenheit is Rankine. Okay, this is the equivalent for Fahrenheit. And difference between Fahrenheit and Rankine is 460. 460. Here, the 0 from Rankine is the same 0 Kelvin. 0 Kelvin at the datum of 0 pressure absolute. You know the absolute pressure 0? Absolute pressure 0. This is at 0 Kelvin, absolute Fahrenheit, everything is 0. No liquid here, no life, no everything. Okay, or 0 absolute. Okay. What is thermal equilibrium? What is meaning of thermal equilibrium? Thermal equilibrium is obtained when touching objects within a system reaches the same temperature. We have two objects touch it together, both going to be at the end at the same temperature. Transfer energy till both have the same temperature now. So there is no temperature difference, there is no heat transfer. So now we can set this in thermal equilibrium. Thermal equilibrium. If this thermal equilibrium is this one, what is mechanical equilibrium? This question not here in the slide. What is mechanical equilibrium? Related to what? Related to what is to be the same?
Mass transfer.
No. Pressure. If the pressure reached to be the same on the system, now we are in mechanical equilibrium. Okay. This thermal equilibrium going to us to Zero's law of thermodynamics. Zero's law of thermodynamics. What is by brief Zero's law of thermodynamics? Zero's law of thermodynamics, he said, if you have two systems and these two systems are separately found, it means not in thermal equilibrium because it's separately, and for thermal equilibrium definition should be touching, but each one of this in thermal equilibrium with a third system. Clear?